the North Island of New Zealand. It's one of the most volcanically active places on the planet. This is a landscape where you can travel back in time. Rotorua is similar to how the early Earth would have looked.
In its early days, the planet looked very different. Just like here, the ground was hot with perpetual volcanic activity. Nasty chemicals brought up from below stained the land. And noxious gases bubbled up from steaming pools.
To us, the young Earth would have been a hellish place. But ironically, this volcanic activity helped create the right conditions for the most important change in the history of our planet.
Ultimately, volcanoes provided the surface of our young planet with warmth, water, and a potent cocktail of chemicals. And it was this combination which inadvertently prepared Earth for an utterly remarkable event. No one's sure exactly how it happened, but around 4 billion years ago, our planet saw the birth of life.
These pools have a unique chemistry that is very similar to what would have existed on the early Earth. Bruce Mountain has studied these pools for many years. He's going to show me how the first life on Earth might have begun.
We don't have a time machine to take us back, so the only thing we can do is look at things that we think are similar to what they were like. And these hot springs are very, very close to those that would be found on the early Earth.
So what's the temperature of this water?
Well, the water's 75 degrees Celsius, so you definitely get burned if you put your finger in there. And it's full of hydrogen sulfide, which is quite poisonous. There's a bit of arsenic in the water as well.
Surely there can't be anything living in there. What am I looking at?
There's billions and billions and billions and billions of organisms living in that water.
Wow.
And they form these orange fibers.
It looks like a fur that's covering all the rocks.
Oh. For the microbes living within the orange fibres, these toxic chemicals in the water are a rich soup of nutrients. Pools like this were very common on the early Earth. Fed by volcanic activity, they provided all the right chemicals needed for the emergence of life.
Deep down below us, there's a body of magma that's very hot. Now, the magma itself is giving off gases like carbon dioxide and sulfur dioxide, and that provides the food for these bacteria to grow.
So the volcanoes are like a supply chain providing all this stuff?
They're the heat engine that drives the whole process.
Volcanic pools like this are one possible place where life might have begun. But there is an alternative theory, as volcanoes created other places where life could have started. Like hydrothermal vents. These too are the result of volcanic activity, but they are found in the deepest parts of the oceans. Today, they support an extraordinary diversity of life. But 4 billion years ago, it's thought that the combination of high temperatures and rich chemicals that the vents produce might have stimulated the emergence of life. But the role of volcanoes went beyond just kick-starting life. They have played a critical role in nurturing and protecting it too.
During Earth's infancy, the sun wasn't burning as brightly as it does today. In fact, it was about 30% cooler. With a dimmer sun bathing the planet in weaker sunlight, Earth was actually in danger of freezing. It was volcanoes that provided the young, vulnerable planet with a way to keep warm, but not in the way that you might think. Earth wasn't warmed up by all that hot lava spewing out. but by an extraordinary gas that volcanoes pumped out. And that gas was carbon dioxide.
Today we think of carbon dioxide as a dangerous gas, causing havoc through climate change. But actually, carbon dioxide has always been vital to our planet, because it traps heat in the atmosphere that would otherwise be lost to space. To see just how critical carbon dioxide is for Earth, take a look at our near neighbours. Mars is a frozen wasteland with an average temperature of -60 degrees. That's because its atmosphere doesn't have enough carbon dioxide to keep it warm. At the other extreme, the temperature on the surface of Venus is hot enough to melt lead. Not simply because it's a bit closer to the Sun, but because Venus has an atmosphere with thousands of times more carbon dioxide than Earth. The early Earth was much more volcanic than it is today because its core was so much hotter. This provided enough carbon dioxide to compensate for the weak sun. It was volcanoes that prevented the young Earth from freezing over. And so early life was able to survive. But even this was not the end of what volcanoes have done for life on Earth. About 600 million years ago, they also helped trigger the greatest evolutionary leap in Earth's history. And a great evolutionary leap was certainly needed, because soon after life got started, it got stuck in a bit of a rut. Shark Bay in Western Australia is home to some of the oldest life forms on Earth. These strange domes are made up from layer upon layer of bacteria. They're called stromatolites. For most of Earth's long history, this was the most advanced life on the planet. For around 2 billion years, stromatolites ruled our world unchallenged. And there was nothing to suggest that this was ever going to change. But Earth and the stromatolites were to face a catastrophe, the most serious crisis life has ever faced. Around 700 million years ago, our planet started to cool. It was the beginning of an ice age, but with a difference. No one is quite sure why it happened, but it seems that ice advanced from the poles until the entire world was plunged into an interminable frozen winter. It's been called a time of Snowball Earth, because the whole planet would have appeared as an icy ball. Travel out to Jupiter and you can get some idea what Earth might have looked like. Europa is one of Jupiter's moons. It's completely covered in ice, just as Earth would have been at the time of the snowball. But knowing what Earth looked like doesn't convey just how terrible the conditions would have been.